All right, guys, our first video for content. So your view will be slightly different than mine, but pretty much the same. If you click on content and move over to introduction to probability, or U1A1 is introduction to probability concepts. So click on that and then content here. Again, for Brightspace, I think you hit this to make it bigger. Bit of a limit there with Brightspace. I'm not sure why it's like that, but anyway, so we're going to go over probabilities here. So this is the first part of MDM for you, which is our course. A couple things to go over. If I mentioned them before, excuse the repetition. When it talks about your journal, the journal is for you. Portfolio is for you. It's not marked. It's kind of your notes. So some things you might want to add to your portfolio for your own notes, depending on how you want to do this. Do you want to make it an electronic version? Do you want to have a notebook, like a traditional notebook that you're writing stuff in? That might be the way to go. I would probably do it that way, because when you do the homework and that sort of thing, you can just do the homework in the notebook also. So just use a regular binder with some paper or a notebook. So this game's fair. You're welcome to go in here and play around with that for a bit, but I'll get on to the section of the course here, the probability part. So probability, we talk about what's going on in life. This is the first part of our course. Probability, you look at where it arises around us, the probability that I can score from this basketball position, what's the probability that it will rain today, what's the probability of winning a lottery, all these different things. There's a quick discussion you can click on and join here and just talk about that real quick. After that, we're going to talk about 3 types of probability in this course. The third one is coming up next. The first one is subjective probability. Some of the subjective probabilities you'll see in your own life. Some of these probabilities are subjective. For example, things like weather predictions, sports outcomes. They are not really math probabilities. If I said to you, hey, what do you think the probability, or what do you think the chance of you getting into university is next year? You might go, I don't know, 50%, 80%. That's kind of a guess, okay? So that's what a subjective probability is. Theoretical probability is what should happen, okay? So this is in most of the time we talk about probability, we're talking about theoretical probability. So things like the likelihood of something happening based on all possible outcomes, it is calculated by dividing the number of ways for something to happen by the total number of possible outcomes. So that is the basic part of probability. When we talk, the basic concept of probability, I should say, when we talk about this sort of thing, in general, what you want to do is when you figure out any sort of probability, what you're going to look at is the number of ways something can happen over the total number of ways anything can happen. Okay, I like to call it like, so it's referred to as NA over NS. Okay, so this, I always do this when I teach it, is the number of ways. So this guy here, like the pound sign, I know it means different things now, hashtag and all that stuff, but it means number in math. So the number of ways, of success divided by total number of ways. Okay, total number of outcomes. So for example, let's go back to what we were just looking at. Give me a second here. For example, when we're talking about dice, if I want to roll a 6 on a regular sided die, success, the number of ways success happens is just 1. There's only one side of the die that is successful. So my numerator, or the top of my fraction, would be 1. And there are 6 total sides on the die. So I have 1 divided by 6. Okay, die singular, dice plural. I always mess that up. Just think of mice, right? Mice plural, right? You have two mouse. It's 2 mice, right? 2 die, 2 dice, right? So 1 over 6. Put this in your calculator. You get 0.167. We'll talk about that after. But let's get to it now. Actually, put this in your calculator to find out the answer as a decimal, and then multiply by 100 to change it to a percent. So 1 divided by 6 will get you 0.166666. Repeating, times that by 100, and then give me that answer right there as a percent. Cards. So let's get to cards in a second. Let's look at cards. There are some things you need to know in this class, and cards is one of them. So if you know your cards, you're great. If not, it's not that difficult. Cards, there are 52 cards. Okay, 52 of them. So there's ace, 2, 3, 4, 5, 6, 7, 8, 9. And these guys here, Jack, Queen, King, usually they don't look like this. Usually they have a face on them. I'll draw a face on them. Okay, these are called face cards. So these are face cards. So there are 52 total cards. Half of the cards are red. Okay, so 26 are red, 26 are black. Excuse my writing. Okay, 26 are red, 26 are black. Of those 26 red cards, we have, yep, you probably know, 13 diamonds, 13 diamonds, 13 hearts. Of the 26 black cards, we have 13 spades, 13 clubs. Okay, these are the suits. There are 4 suits. Clubs, hearts, spades, diamonds. Okay, black, red, black, red. Each of them have all of the same cards. Starts with an ace or ends with an ace, up to you. And then goes 2, 3, 4, 5, 6, 7, 8, 9. These are numbered cards. These are face cards. They have a face on them usually. They're called face cards. So how many face cards are there? 3, 6, 9, 12. So there are 12 face cards. Okay. There are 4 aces, 4 twos, 4 threes, 4 of everything. And if you say no is a 10 and a face card, just remember that these guys usually have a face on them. Okay. So that's it. Ace, all the way through king, 13 here. So if the question was, let's go back to the question. The question is, what's the probability of drawing an ace? Okay. You go back and you count the aces. There's 4 of them. And there are 52 total cards. Success over total, 4 over 52. As a fraction, you could write that as lowest terms to 1 over 13. Sometimes writing fractions in lowest terms is good for probability, but not always. We'll get into that a bit later. And then when you divide this out, you get 0.0769 on your calculator and multiply that by 100 to get 7.69%. You get a spinner like this. If I said spin one specific section, there's 9 sides here, and I said, what's the probability of success? You would say 1 over 9, right? So if I said one specific thing, a green, let's say this is only green. There's one green, 9 total outcomes. So that's it for your introduction to probability. I do want to go over a couple things. If I say things like this, what's the probability of spinning a yellow or a green? So we'll just call that yellow and the green. So these two are just yellow and green. If it's that, then you have 2 successes, yellow and green. 1 plus 1 is 2. 2 successes in total, and that'll be 2 over 9 as your probability success. There's a games fair you can go around and play with, but then what I really want you to get to, so all this here, this is reflection. This is getting used to this sort of thing. And then there's a little disclaimer here about what's going on. We talk about probability notation. So, and we talk about set notation. So when you talk about set notation, if I said A is a set, so if we use A to represent the set A, this is a set of all elements that you want to count or find the probability of its winning outcomes. If rolling a 6 is the objective of the game, A is the set of all the ways to roll a 6. A lot of words there to just say, look, what am I doing here? I'm rolling an A. How many ways can I roll? Or so rolling a 6. How many ways can I roll a 6? Just once, just by getting a 6. Okay. So when I look at different things and I talk about sets, okay, and sample sizes and that sort of thing, what you do here is you use the right notation. So let me go over that real quick, how that works. Set notation. So if I said to you, I'll do a different example here. If I said to you, let S represent all the letters in the word, let's just make it easy, tuba. Okay. If I said let S represent all the words in the word tuba, letters in the word tuba, and I want to have so let S be the set. I should have written there, be the set. What you do is set S equals, and you use this weird bracket that looks a little nicer than that. Okay. So it looks something like this. Okay. I don't know if I'm making that any better. Okay. It is found on your on your computer. And you can go back and take a look at what it looks like. You open the set with that bracket and you close it with that bracket, and then you put every element in the set separate, so T-U-B-A, and you put commas between them. Okay, so that is the set S of all the letters in tuba. If I said now, give me the set V, which is just the vowels in tuba, okay, again, you want to go through this and put U, or open the set and then close the set at the back, and we have U and A as our vowels, okay? The next thing we want to look at for this is if I said, what is NS? That means how many elements, these are all the elements, 1, 2, 3, 4. How many elements are there in S? And this is called the cardinality of a set, okay? Or the size of a set. And if I said, what's NV? You would write that as 2. So we have set notation. We have the size of a set. We have, what else do we have? I think that's about it for this. So if I said, what's the probability if I chose a letter at random that it is a vowel? what I would do is I would take NV, which is my success in this case, which is 2, and I would divide it by NS, which is 4, so I get 2 out of 4, which is 50% or 0.5, or 1/2. Okay, so that's a little bit on set notation and that sort of thing. Okay, so let's go back real quick to our class and see what else we have here. So that's how you write that. The probability of an event happening is the number of ways that can happen over the total number of elements in the set. Okay, so again, back to this. If we wrote this as set notation, I said give me all of the possible outcomes of rolling a die. You would have one. You'd have open the bracket, 1, 2, 3, 4, 5, 6. Close the bracket. Okay, so you'd have 6 things. So it looks just like this. Okay, those are all the elements in S. And if I said, what's the probability of rolling a 6? Well, there's only one element in A, which is in this case rolling a 6. So it would be 1/6. That's it. Okay. So all these things here, you look at some more stuff like this that we looked at. The complement is the probability of something not happening. So if we go back to the question above, the number of elements in A, which are all the ways of rolling a 6, is just the one thing, right? The 6. What are the things not in A, or A complement? So we write it with a little, I don't know, you can either put a little C here. So they wrote it 2 different ways. It's either A with a dash or A with a C. Okay, so like an apostrophe or a C. Usually we do this. Okay, we usually do the guy over here with the apostrophe. So A complement is everything not in A that is in S. So if I go back to S, it was 1, 2, 3, 4, 5, 6. What was in A was 6. Everything else is in A complement. And the probability of A complement happening is NA complement over NS. So there are 5 guys that are not in A, or 5 guys in A complement. That goes there. And there are 6 in total, so that goes there. There's another way to do that, and you probably may have worked this out. If you know that something has a probability, and you want to know the probability of the other thing happening, the complement happening, what you do is you take 1 or 100% and you subtract the probability of the complement happening from it, or vice versa. Okay, so what I'm saying here is if I knew that there's a 1 in 6 chance of rolling a 6, then there has to be 1 subtract 1 6, which is 5 6 chance of it not happening. Okay, this is easy to think about as a decimal. Okay, maybe a little bit easier with decimal. So for example, let's go back to our tuba example. Give me a second right here. If I said, what's the probability now? If I came back and said, what's the probability of not a vowel? What I would do is I would look at the probability of a vowel was 2 out of 4, which is 0.5. Okay, and if I said, what's the probability of not a vowel? I take 1 and I subtract 0.5 from it. Okay, in this case, it's the same. It is 0.5, but it doesn't have to be, right? Because there are 2 non-vowels. There's this guy and this guy. Okay, if I wanted to know what is in not V, it would be D and B, and the N of this, if I said, what's the size of this, it would be 2 also. Okay, so you can do it in both ways. All right, so that's the intro to probability. The last thing I want to look at, though, is this before I move on. You will have to know how this works. So I would definitely have this written down in my portfolio, because you're going to be asked questions about this all year long. It's about rolling 2 die. Okay, so if you roll 2 die, your outcome can be 2. You get a 1 and 1, you get a 2. You get a 2 and a 2, you get 3 all the way through here. The highest number you get is 12. And what you notice here, I will go through this real quick with you. I got another minute before this video cuts out. I like to keep these videos to 15 minutes. A, because that's how long my free version of this is, and B, usually people stop listening. Okay, so if I go through this and I say, how many ways can you get a 2? How many ways can you get a 3? How many ways can you get all the way through? What you notice, if I have, this is the total, and this is the number of occurrences. So if I said N of A, okay, 2 can happen once, 3 can happen twice, 4 can happen 3 times, 5 can happen 4 times, 6 can happen 5 times, 7 is the most common. It goes 1, 2, 3, 4, 5, 6 times. Okay, 8 can happen 5 times, and then it gets smaller and smaller. There's a nice symmetry here. Okay, and what you notice is all these numbers. It starts with 2 is as often as 12, right? Once. 3, 3, twice. 11, 11, twice. 3, 4, and it maxes out at 6, which is 7. You're going to be asked about rolling doubles. Rolling doubles are rolling a 1 and a 1. Okay, rolling a 2 and a 2. So these are your rolling doubles. And you're also going to be asked things like, what's the probability of rolling certain things?